Okay. Well, good morning and good afternoon, everyone. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. Now, in today's hands-on workshop, we have Kathryn Sizemore, who's a director of solution engineering here at PingCAP, and she's going to show you how TiDB can transform your SaaS workflows. You'll gain hands-on experience using multi-tenancy resource controls to handle numerous customers with diverse workloads. At a high level, here's some of the things we're going to be talking about in today's workshop. We're going to kick things off with an overview of TiDB and how it enhances the flexibility, performance, and efficiency of SaaS applications. We're then going to show how TiDB's scalability and multi-tenancy features address some of the most challenging SaaS requirements. And then finally, and we say hands-on in the title, there's going to be hands-on labs focused on creating thousands of schemas and tables, performing seamless online schema changes, and even applying global execution plan bindings to standardize query execution across multiple schemas. Now, before we get started, Ben and Stephen from our solutions engineering team are online. So please feel free to drop any questions you may have directly into the chat window, and they'll answer them as quickly as they can. Ben and Stephen will also facilitate virtual breakout rooms throughout the workshop to ensure you have a dedicated expert ready to help you at every turn. Now let's get ready to have some fun. I'd like to hand the reins now over to Kathryn. Kathryn, the floor is yours.
Thank you, Brian, for that introduction. I'd like to also welcome you all to today's hands-on lab. It's the first that we're doing here virtually at TiDB. So we'll, like Brian said, this will be an interactive session where you'll not only learn by doing, but see firsthand why leading SaaS platforms are adopting TiDB to power their next generation of growth. Let me just introduce myself briefly here. Yes, I am the director of solution engineering here in North America. I'm from California, the Bay Area. I've been a database administrator, a cloud architect, a database consultant for over a decade, and have lots of hands-on experience with multiple database platforms. Now let's get into scaling SaaS databases. The main challenge of scaling SaaS is managing exponential customer and data growth, right? It's not the same as some individual database users. The more customers you have, that data just expands rapidly, and you're dealing with performance issues, etc. So first, scalability is what we'll cover today. How do we achieve scalability with our database that other databases can't? Reliability, having high availability and the ability to be always up, number of nines, right, is always important for SaaS. Performance, how do we scale without losing our performance? And then ensuring that we have the best possible customer experience with these main items, right? So first, I would like to look at a real-world production customer that is using TiDB. We have achieved over 1.2 petabytes of data in a single TiDB cluster, with over 10 million tables and a peak query per second of 2.6 million. Okay, this is far beyond anything I'd seen at MySQL or MariaDB, even Postgres. These are well beyond the limitations of standard transactional databases. So here's another customer that re-architected their SaaS platform with TiDB and was able to achieve 60 times the query performance boost by doing that. The challenge was both scalability and complex analytics. With what they were using was Postgres and Elasticsearch, was really giving them challenges, especially with schema changes and high infrastructure costs. So they went with TiDB Cloud Dedicated, which gave them real-time data integration and linear scalability, as well as online schema change. So huge improvements there, as well as a result of that 60-time query performance improvement. Really impressive performance boost for Catalyst. Atlassian is another great example of a SaaS customer that has greatly benefited from TiDB. They are able to scale to millions of tables and maintain multi-tenancy within a single TiDB cluster for their customers. Their challenge was that no database could handle the millions of tables that they needed to be multi-tenant, to put all of their customers on the same database cluster with one schema per tenant. Traditional single node databases required thousands of instances, leading to database sprawl, complexity and scaling, backups, upgrade complexity. They really wanted a simpler solution. And so with TiDB self-managed, they were able to do over 3 million tables hosted in a single cluster. Again, online schema change without impact to the performance or customers. They were able to do within seconds, and horizontally scale with 40,000 queries per second. So this is a massive reduction in instances. Aurora would have required 100 times the number of instances to achieve the same kind of result. And they were able to create 100,000 tables within 4 minutes. Now, this is really important when spinning up customers. You don't want lag or a delay in spinning up customers and losing that potential revenue. They also achieved zero downtime with rolling restarts, fast backup recovery, and like I said, the online schema change as well. So huge benefit for Atlassian SaaS product. All right, so that's kind of the background. Let's jump into what we'll be doing today in this specific lab. So our lab is practical database features for SaaS applications. And as part of that, we'll start with a brief overview of the lab, and then we'll jump into module 1. And module 1 will be simulating what Atlassian was able to perform, right? Rapidly creating a large number of schemas and tables. Module 2 will be cross-schema execution plans and bindings, and this is to ensure performance consistency for customers. Many other database execution plans will be inconsistent, but with TiDB, we can lock down those execution plans so that performance is consistent for those queries, regardless of situation or data behind it. And then module 3, managing system resources for multi-tenancy environment. And this is where we get into preventing one user or a runaway query, or maybe a free tier customer from eating up all of those resources and impacting performance of other customers. And finally, module 4 will be testing that online schema change and seeing how quick it is to perform and the lack of impact on other sessions. So that's the main 4 modules we'll be doing today. And we'll do a quick wrap up at the end. Let's get started for today's lab. So first, go ahead and open your browsers and go to the address labs.tidb.io right here. Remember, if at any time you have any questions or issues, you can put a message in the chat or join one of our breakout rooms with Ben and Stephen. Let me pull up TiDB, labs.tidb.io right here. First thing you're going to do is go to that sign in at the top right, and you'll probably need to create an account with us, sign in with TiDB Cloud. I'm already logged in, I think. Yes. So the next step will be creating that account, whether you connect it to your Google or one of the other options. Go ahead and create an account. And then the next step is authorizing permission to use your cloud account with TiDB Labs. So I'll go ahead and authorize, and I'll give everyone a second to get to this step. Okay, hopefully you're getting close. If you're having any issues, again, you can go into the chat or you can join one of those breakout rooms with Ben or Stephen. The next step is to redeem this event credit. So we have a special credit so you can join today's lab for free. This is the code you'll enter, and let me go to the next page here. Once you're logged in, your name will be at the top right. And when I click down, I can redeem. And then we'll type in this voucher code into that redeem box. Okay, redeem. I already had redeemed this voucher, but yours should go through just fine. I'll give you a second with that code. Okay. Next, to go into the lab, we're going to click on your name again at the top right and go down to workshops. And once you've redeemed the code, there should be an active workshop available to you. And as you scroll over, this is the lab that we're doing today: practical database features for SaaS applications. Stephen or Ben, can you put the code in the chat maybe?
I did it.
Thank you. Thank you. Okay, so I'm going to go ahead and enter. If you're not on this step yet, again, put a question in the chat or go ahead and join one of those breakout rooms. All right, so let me zoom in because I'm sure that's small on your screen. Okay, so here's our lab. I'm going to switch it to the Oregon region because that's what's closest for me. And I'm going to click start. This may take a quick minute to get kicked off, so let's start that right now. Okay, you can see there's 5 steps, so it's going to go through pretty quickly. So as we go through this lab, you can see the modules on the right that we'll be going through. Each step is designed to be hands-on, but also demonstrate that real business value of switching to TiDB, right? Faster growth, reduced infrastructure cost, happier customers. All of these things lead to rapidly scaling SaaS. While that takes a minute, let's look briefly at why TiDB can do these things, right? So we're able to limitlessly scale performance and efficiency for modern SaaS platforms. And part of that is because we're a distributed platform. I said earlier that this is far beyond the limits of Postgres and MySQL. Well, let's dig into that a little bit more. So there's the traditional databases, Postgres, MySQL, that are ACID compliant, full SQL, have data integrity. But when you get to real scale, we have sharding complexity, operational complexity, et cetera. NoSQL was the reaction to that. NoSQL is things like MongoDB, Cassandra, HBase. It provided higher scalability, flexible schemas, but it didn't have the rigidity and structure that traditional databases did, which made it more difficult to get data back out, right? When you're trying to do complex queries and whatnot, it can be very difficult to get that data back out. So distributed SQL was created as the best of both worlds, providing scalability and reliability of NoSQL with the same functionality of the transactional, right? The structured. And just really briefly, I'm not going to dig too deep into the architecture while we're still spinning up the lab. We're able to do that because we've decoupled compute and data, which means we're able to scale those independently. We're not just scaling up a whole system. We're able to scale up where we actually need it. And we've distributed the data portion to multiple nodes. So we can horizontally scale where traditional databases are unable to. Let's see. Okay, almost done. There we go. So mine's up and running. Hopefully yours is about to be finished as well. Let's jump into module 1. So first, on the left-hand side, I have a resources button, and these show all the virtual machines that were spun up by the lab for us. You can see these are our data nodes, and this is our compute node, and this is kind of like our brain that is going to be behind the scenes, as well as a monitor that provides our monitoring tools as well. So module 1. Right, we're going to start by rapidly creating a large number of schemas and tables, and we won't get to 1 million because that would take some time, but we're going to do several thousands here. First, we'll open that web SSH. There's also a button here for terminal 1. And there we go. I've got a connection already. If you scroll down, you'll get that first step 2. So we're going to make sure the cluster is healthy and running. We're going to review that cluster status. Just copy and paste into that terminal. And you can see that all those nodes that we just looked up in resources are up and healthy on the right-hand side for me. Next step, we're going to connect to our database there. And we're going to enable some fast creation variables. So this is the first one, TiDB enable fast create table. Good to go. And I'm going to also look at schema cache size. I want it to be fairly significant for us for this endeavor. All right, with those 2 variables looking good, we're going to exit and prepare our sysbench that will be creating all those tables. So next, we're going to clone that sysbench configuration. We're going to copy this configuration to set up sysbench. And it's looking good here. It's got the right connection information now and the right setup, just like in my sample output. Now we're actually going to create those 1,000 tables. And I just pasted it in there, and it's already spinning up all the databases. Once it's done with the databases, it'll start on those tables. This should take a little bit of time. So if you're not there yet, don't worry, because this is going to run for a few minutes. Again, if you're having any issues, please jump into those breakout rooms so that we're all on the same page. Ben and Stephen are eager to help you. Now, like I said, this is going to take a few minutes, so let's try to jump back over to our PowerPoint here. Okay. So why is this important? Why are we creating all of these tables? We know Atlassian needed it, but let's talk about that more specifically. So here's an example of a server, one of our server databases, where each customer gets their own database in a SaaS world, and as part of that, all of those databases have to have unique tables, right? Customer A has, let's say, 100 tables, customer B has 100 tables, customer C, and we quickly reach the limits of what traditional databases can hold. Why? Because the table limits exist. There is metadata bloat that causes performance to lag when all of the table information is in the metadata. Query performance declines, database scales, we're at a hard limitation for most databases, and it limits the number of customers we can have per server before it's overloaded and has serious issues. All right, let's see. Still creating on my end. And you can see now it's really chugging away. It's creating 10,000 ready to use tables in just a couple of minutes. In a real world SaaS use case, this means that whenever new customers sign up, their environments are ready to use instantly without DBAs babysitting the process or any kind of lag, right? Now we're inserting hundreds of records into those tables very, very, very quickly. Oh, there we go. So the next step is to verify those schemas that we created. I'm going to copy our connection string here and then show those databases. You can see they're all there. I'm not going to, there's 106 rows. That sounds about right. I'm going to do a count from one of the tables. And you can see those 100 records were inserted there. So just kind of a quick check, all of that processed successfully. If you're not here yet, that's okay. It should be finishing up soon. But you can see how TiDB can rapidly provision thousands of tenants environments in parallel without performance degradation. And this is exactly the kind of efficiency that SaaS platforms need to keep onboarding costs down and scale profitably. So when you're ready, we'll click into the next module and go into some execution plan binding to maintain good performance. Again, if you're having any issues, go ahead and jump into those breakout rooms, and Stephen and Ben would love to help you out. Okay, so cross-schema execution plan binding. That's quite the mouthful, but our module 2 is about making sure that query execution is consistent across tenants. That's consistency and performance consistency is one of the biggest challenges for SaaS databases. The reality for SaaS platforms is that every customer might run the same type of workload, but because the differences in data distribution or table statistics or the optimizer in traditional databases can choose wildly different execution plans. And so some tenants will get lightning fast performance while others complain about queries dragging. So by creating these bindings for execution plans, we can offer much more consistent performance across tenants. So let us jump into that. Step one is to enable the cross schema execution plan binding. So I'll just copy and paste into our same terminal. You can see that it is off. We're not going to do fuzzy bindings, or we currently don't have fuzzy bindings, and we're going to turn that on. So we've set that global variable to 1 and set the local variable to 1. And now when I look at that variable, it is on. Next, we're going to create the cross schema binding execution plan. So you can see I've got 2 table schemas that we just looked at. Now we're going to explain a couple of queries for those tables. And you can see this is the explain plan. This is our execution plan that it would use. Now, acting as a DBA in this scenario, we're going to bind a hash join instead of a merge join. You can see a merge join was used here and here. We're going to create a binding that makes it use a hash join for these queries. Now, when we show bindings, those hash join bindings should exist. And then lastly, we're going to verify the bindings with the explain plan. And now we're using hash joins instead of the merge join that we did have. Okay. Okay, so this was a pretty easy one. Let's go ahead and remove those bindings so we can move on to the next section. Again, I probably moved a little fast, so if you have any questions or need any help, Ben and Stephen are in those breakout rooms for you. So what we've seen in module 2 before we move on is that the cross schema execution plan binding gives you the ability to guarantee consistent performance across thousands of tenants with a single command. This is really helpful for dealing with unpredictable performance and noisy support queries that don't perform well. Next, let's move on to module 3, managing system resources for multi-tenancy. Let's see if I can switch over real quick before we jump into that. And we'll look at why this is important. This is the noisy neighbor problem. The noisy neighbor problem is when you use shared DBs, a single database with multiple schemas, so multiple tenants per schema. Each customer has their own database, just like we looked at before. But one actor or one query or one user eats up all the resources, right? So a runaway query, a customer just hammering the database uses all the resources on that system because there's no limitations, and causes performance issues for everyone else, which can even take down the system in some cases, right? So we want to avoid the noisy neighbor problem. And we can do that easily with TiDB, with resource management, specifically created for multi-tenancy. So let's jump in. Hopefully you're all here. If not, again, we have support for you. Let's jump into the multi-tenancy setup. So we're back at our terminal, and I'm going to copy that step 1 to create 2 different users. These are going to be our scenario of 2 different performance users. Once you've created those users, we're just going to exit. And we're going to create a second terminal. So we haven't done that before. So you can click this button here for terminal 2, or you can add another one at the top. Okay. So after you've logged into that second terminal, we're going to do sample workloads in the first terminal and the second terminal. So in fact, I'm going to open a third one for us here. So this is terminal 1, this is terminal 2 that we'll be using. We're going to copy the following command into terminal 1, which will be our first example, and it's already running right now that I've hit enter, giving us certain queries per second. Now we're going to copy the second text into terminal 2. And it's also doing that sysbench, and it is also showing our queries per second here. You can see we're at about just as predicted. We're in the 70s for TPS and about 1400-ish for our queries per second. If we go to the other terminal, it's about the same. So we're getting about equivalent performance between the two. This is our baseline. This is an example of both tenants treated equally by default, getting about the same performance, right? We don't have a runaway situation. This is just a starting baseline. Next, we'll set some resource quotas right here. We'll log in again to either terminal. We just need to get into the TiDB prompt. And here we're going to set some resource groups. So we're creating a free tier and a premium tier with 2 different resource unit constraints. And then we'll do a test to see how that changes their performance. Okay, you can see it was all set successfully for me. So I'll go into terminal 1 now, and I'll use our sysbench here. And I'll go into terminal 2 and set this sysbench. And now we should see different performance. So terminal 1, I'm getting 20-ish TPS and about 400-ish queries per second. That's our heavily restricted one. And then if I go to terminal 2, it's got the full performance here, almost 80 TPS, 70 something TPS, and around 1500 queries per second. So you can obviously see, even if without remembering. Terminal 2 is running that premium setting, and Terminal 1 has got that free tier. Okay. Okay, so pretty powerful stuff, being able to control and allocate resources per tenant. We do have other options available to fine tune this even more, but you can see how this can easily eliminate that noisy neighbor problem, allow you to consolidate systems, consolidate databases, consolidate customers onto a single system to reduce your cost and give you a clear path to monetizing different service tiers. So next, and again, if you're having any issues, go ahead and ask. But next is our module 4, online schema change. And this is our last module for today. So going back to Terminal 1, we are going to test that ability of staying online 24/7, even when we have to change schema. Let's log back into MySQL. We're going to look at the definition of one of our tables here. And this isn't very pretty, but you can see our definition here. Okay, so now we're going to prepare for the schema change. We're going to disable the metadata lock, which in legacy systems, it locks block operations during DDL. So nothing can change, and it can provide, it can restrict access to that table, which could cause performance issues. But in TiDB, we bypass that. So the data DML, the data manipulation, can keep flowing while we alter the schema. So we're going to look right here. This is still preparing it. Here it's saying our code is going to keep trying if there's a problem. Let's start that insertion workload that's going to keep inserting records while we perform the schema change, so we can see what happens during the schema change. If there's an error, it'll throw us an error. Okay. There we go. We've started inserting. Now in a second terminal, we're going to paste that MySQL prompt again. And we're just going to double check that that insertion is working, and it is. It's increasing, right? And now we'll perform the DDL. So we're going to add a column of our column to the table and see how that impacts our insertion on the other terminal. So that took very few seconds. I just got a quick schema mutation encountered error, but it was able to immediately retry. So the workload was not interrupted, which was the important part. Now we'll go back into Terminal 2 again and see that the insertion is still going on successfully. Let's double check that the table actually changed. And it did. So the inserts never actually stopped. The schema now includes the row ED, which we added, that last row. And this shows that TiDB can evolve your schema in real time while your SaaS business stays fully online. Okay, so we made it all the way through. You've done 4 modules showing how TiDB can help SaaS grow. We did effortless scaling. We created 1,000 table or 10,000 tables across 1,000 schemas in just minutes, showing how TiDB can help onboard thousands of new customers all within the same cluster without bottlenecks. We showed off predictable performance with binding execution plans. We can ensure that performance is consistent across customers and has stable execute query plans across all tenants, cutting down on potential support tickets and SLA risks with that consistent performance. And then we also looked at the noisy neighbor problem, resource control, allowing us to prioritize premium tenants, throttle free users, and make sure that performance is not impacted by a single noisy neighbor, delivering cost efficiency by allowing us to consolidate all those customers onto a single cluster and ensuring customer satisfaction. And this final module that we just finished, we showed always on innovation, which is our online schema change ability. You can evolve your SaaS product without any downtime and keep your customers online while you ship new features. So these aren't just database features, these are business enablers, where we hope that you are able to use all this in your own system, whether you're doing SaaS or not, because they are critical to customer performance across the board. So with TiDB, we hope you can scale your systems without the growing pains that usually exist. All right, that's all for today's lab. Thank you all for joining. And I hope you got a lot out of it. I don't know, Brian, do you want to close us out?
Yes, absolutely. And again, thank you, Kathryn, for the excellent, kind of hands-on workshop and deep dive into this topic. And everyone, again, thank you for kind of sticking with us throughout this workshop. We hope you enjoyed the content throughout, and hopefully you're able to learn something that you didn't know before. As we mentioned, or we may not have mentioned it earlier, we will make a recording available to everyone who registered for the event in the coming days. So definitely stay tuned for that. And of course, like I said, you saw a lot of different labs. You saw the environment Kathryn was in. If you'd like to learn more about about TiDB even in more depth, or just explore other labs, please visit our website at tidb.io. So with that, again, thank you all again. Really appreciate your time, and we'll hope to see you on another hands-on workshop.
Thanks, so.
Thank you, everyone.